Students, you have studied algebraic expressions, their addition, subtraction, multiplication and division in your earlier classes. Also, you have studied some algebraic identities like a plus b whole square, a minus b whole square, a square minus b square and so on. I think your concept is clear about term and coefficient, variable and constant, exponents and powers. Now we start discuss a particular type of algebraic expression called polynomials. Before going to start the polynomials, we will discuss some few points. So these all are algebraic expression. So in algebraic expression, it involves a variable and constant. Okay. What is the variable? Variable basically we consider the variable is denoted by the alphabet x, y, z or abc. The variable. As for example, suppose in the rectangle, this is a rectangle. The length is x and breadth is y. What is the perimeter? Perimeter is 2x plus 1. Okay. In this case, xy is called variable. Why variable? Because they have no fixed value. If you put x equal to, suppose, put x equal to 2 and y is equal to 1, then what is the answer? 2 plus 1, 3, 3 to the 6. Okay. Or if you put x equal to 3 and y equal to 1, so 3 plus 1, 4, 4 to the, understand? So that means these values depends on x and y. So the value x and y can be changes. So therefore it is called variable. Okay. And what is the constant? This is the constant value. 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 Why constant? Because they cannot be changes. This is 4 means 4, always 4. This is 2 means 2, always 2. So this is the fixed value. Fixed value is called the constant. Next, term and coefficient. What is called term? In this first one example, how many terms? 1, 2, 3. How you know this is the 3 terms? So term is separated by the positive or negative sign. So how many terms here? 3 terms, because this is these 2 terms separated by plus sign. These 2 terms is also separated by plus sign. So therefore there is 3 terms. In this case also 3 terms. So this plus and minus. So these 2 terms separated by positive sign. These 2 terms separated by negative sign. So there are 3 terms. This is 2 term. This is 1 term, 1 term, 1 term, 2 term, 3 term. Okay. So this is called term. And what is the coefficient? Coefficient means, you see here. So coefficient already discussed in from class 8 also. So this is called coefficient. The 3 is the coefficient of x square. Understand? Similarly, this 3 is a coefficient of x. This 4 is a coefficient of x cube. This 3 is a coefficient of x. So this is the coefficient. And exponents are power. So this is called power. You see, this one is called power or exponent. Yes. In this case, the power is 1. Yes. In this case, power is 2. In this case, power is also 2. Suppose another example, 4x to the power 4 plus 3x. What is the power? This is the power, this is also power. So understand power? Definition of polynomial. An algebraic expression is a polynomial if the power of the variable is a whole number. And highest power of the polynomial is called a degree. Clear? The polynomial is generally denoted by px. I read some example of algebraic expression. So these all are algebraic expression. So then from this algebraic expression, we find out which one is polynomial and which one is not a polynomial. See the first one. The definition is expression is a polynomial if the power of the variable is a whole number. Whole number is starting from 0 to infinity. 0, 1, 2, 3, like that. So power is a whole number. So what is the power of this term? 4. Power of this term is 2 and this is the constant. So this is a polynomial because all power is a whole number. This is, you see, this is the variable. What is the power? 1. This is the constant. So this is also a polynomial. This is x. The power is 1. Only use Check the power of the variable. So this is also a polynomial. Similarly, you see this one. What is the power of x? 4. This is power of x square. And this is constant. This is only constant. You check the power of variable is a whole number. So this is also polynomial. And this one you see, this is x, the power is 1. And this one is 1 by x. The power is minus 1. So according to definition, power of the variable is a whole number. Is a whole number means it should be positive. Okay, it should be positive, but it is negative, so it is not a polynomial. Similarly, you see this one, x cube, power is a whole number, power is also a whole number, this is constant. So therefore this is a polynomial. This one you see, x, what is the power? 1. And this is root over x. What is the power? The power of root over x is half. This is not a whole number. This is not a whole number. This is not a whole number. This is a fraction. So it is not a polynomial. Understand? This is not a polynomial. And this one you see, 8x cube plus 3x plus 9. So power is 3. In this term power is 1 and this is constant. So therefore this is a polynomial. So understand everybody? So next types of polynomial. Students, listen carefully and write down in your copy. Okay? So constant polynomial. Constant polynomial means suppose the px is a polynomial, so it should be value is constant. Suppose 4 or suppose 5 or suppose 100. So this is called a constant polynomial. So always the value of px is always constant. So this is constant polynomial, and degree of the constant polynomial is 0. What is the degree of this polynomial? 4. 4, that means you can write x to the power 0, because x to the power 0 is always 1. Degree is always 0. 0 polynomial. So 0 polynomial means it is px is always 0. The value of the polynomial is always 0. Value of the polynomial is always 0, and degree is not defined. Degree is not defined. Okay. Next, linear polynomial. Linear polynomial form is ax plus b. Okay. Linear polynomial, or for example 2x plus 3, like that. Okay. This is the one variable, or you can write the two variable also. 2y plus 3x. So you can write two variable also. Degree is 1. Degree is equal to 1. Quadratic polynomial. A quadratic polynomial, the degree is 2. As for example, px equal to ax square plus bx plus c. So this is the quadratic polynomial. Degree is always 2. In this case, a is not equal to 0, because if a is 0, then it becomes linear. Clear? So it becomes linear. So this is the quadratic polynomial. This already discussed in class 9. Cubic polynomial. In cubic polynomial, degree is 3. In this case, degree is 2. Degree is 2. And this case, degree is 3. Degree is 3. Degree is 3. So what is the standard form? Px equal to ax cube plus bx square plus cx plus d. Okay. So degree is 3. And biquadratic polynomial, degree is 4. Degree is equal to 4. So you understand, everybody? Now zeros of the polynomial. Zeros of a polynomial is that value of the variable for which entire value of the polynomial is 0. So for example, number 1. Suppose px is equal to x plus 3. So this is a polynomial, and this is a linear polynomial. Okay, this is a linear polynomial. So according to definition, zeros of the polynomial is that value of the variable. That value of the variable means the value of the variable x, for which entire value of the polynomial is 0. When px becomes 0? When px becomes 0, if you put x equal to -3, then it becomes 0. Okay? So that means for which entire values of the polynomial is 0. If the variable of x equal to -3, then entire polynomial, that means px, the value of the px becomes 0. So therefore x equal to -3 is a 0 of px, because if you put x equal to -3, then px becomes 0. Understand? Number 2, suppose second example, px equal to suppose x square minus 1. So this is linear quadratic polynomial. What quadratic polynomial? Because the degree is 2. If you put 1 in place of 1, x equal to 1, then it becomes 1 minus 1 equal to 0. So that means for x equal to 1, the px becomes 0. So therefore 1 is a 0 of this polynomial. So again you remember another point. See here, if you put -1 again, then again you get 0. -1 square equal to 1. So 1 minus 1 equal to 0. If you put -1, then it becomes 0. That means in this polynomial there is 2 zeros. One is 1, other is -1. So 2 zeros. So x equal to 1 and -1 are the zeros. So that means we can conclude that from this example, the degree is 2. That means in quadratic polynomial there are 2 zeros. In a linear polynomial, 1 zeros. If degree 1, so 1 0. Degree 2, so 2 0. That means number of zeros equal to number of degrees. Again, it's the constant polynomial. For constant polynomial, for example, px equal to suppose 100. What about p1? P1 is also 100. What about p0? P0 is also 100. That means if you change the value of x, then it becomes 100. Always 100. No changes. So therefore this is a constant polynomial. So in constant polynomial there are no zeros. Why no zeros? Because in constant polynomial degree is 0. So degree of 0 means, according to our conclusion, so number of degrees equal to number of zeros. So degree is zeros means in this case no zeros. So understand? Now graphical representation of zeros. Now we draw a graph. Suppose px equal to x minus 1. Okay? Draw the graph. Try to draw graph. X axis and this is y axis. This is 1, this is 2, this is 3. 1, 2, 3. Okay? So if you put p1, then it becomes 0. If you put p2, then 2 minus 1. 2 minus 1 is 1. If you put p3, 3 minus 1. 3 minus 1 is 3 minus 1 is 2, and so on. Okay? That means if x equal to 1, then this value actually y. Px means y. Okay? Then what is the coordinate of this one? If 1, then it becomes 0. If 2, then it becomes 1. If 3, it becomes 2. Then plot this point in your graph paper. So 1, 0. 1 becomes, if 1, then y equal to 0. 2, then 1. 2, then 1. This one. 3, then 2. 3, then 2. So this is your graph. This is your graph. Okay, and this graph is x minus 1. So you observe from the graph, when y equal to 0, y means px. When px equal to 0 means y equal to 0. From this graph, in this point, the x equal to 1, then the value of y becomes 0. So therefore, this point is called the zeros of this polynomial. And this is the linear, because the graph of the linear polynomial is always a straight line. Clear? So another graph, you see another graph, suppose here. This is suppose. This is suppose -1. This is 1. This is 2. So how many zeros? So number of zeros is 2 because these 2 points. In these 2 points, the px becomes 0. So number of zeros is 2. What is the value of zeros? -1 and 2. So from this graph we can conclude that this is a quadratic polynomial. Why quadratic polynomial? In a quadratic polynomial, 2 zeros. So from this graph indicate 2 zeros also. So therefore this graph is the polynomial of this graph is a quadratic polynomial. So understand? Find the number of zeros. So from the first graph, how many zeros are there? So you just observe the x-axis, intersecting point of x-axis. Clear? So how many intersecting points on x-axis? 3 intersecting points. 1, 2, 3. That means in this graph passes the 3 point on x-axis. So therefore number of zeros is 3. This is the number of zeros is 3. What is the value of zeros? -1, 1 and 2. And this is a cubic polynomial because number of zeros is 3. So it is cubic polynomial. Clear? In this case you see how many number of zeros? No zeros because the no intersecting point on x-axis. This graph not intersect in x-axis. So therefore no intersecting point on x-axis means in this graph no zeros. Understand? No zeros. Next, third example. This is x-axis, this is y-axis, and this is your graph parallel to y-axis. Okay. So how many intersecting point on x-axis? Only one point of intersecting point. This point. So that means only one intersecting point means the number of zeros is 1 and the value of zeros is 2. So this is the linear because it is straight line. And last example you see number of zeros is 2, 0 and 1. These 2 points. So intersecting 2 points on x-axis. So 0 and 1 are the zeros of this polynomial. And this polynomial is a quadratic polynomial because 2 zeros. Okay. Relation between zeros and coefficient of a quadratic polynomial. So now we discuss the relation of zeros and coefficient of quadratic polynomial. So I think everybody is clear about the quadratic polynomial. What is the degrees of quadratic polynomial? 2. Degree is 2. And if degree is 2, so the number of zeros is also 2 because the number of zeros and number of degrees are same. Okay. Let px suppose ax square plus bx plus c where a is not equal to 0 is a quadratic polynomial. Okay, this is already discussed. It's a standard form of quadratic polynomial. Now, if you take common a is a common, then it becomes x squared b by ax plus c by a. Okay. Now, x equal to alpha and beta are the zeros of px. 2 zeros, alpha and beta. Because this is quadratic polynomial, so therefore number of zeros is 2. One is alpha, another is beta. Understand? So if alpha and beta be the zeros of this polynomial, so then you can write x minus alpha and x minus beta is a factor of px. Okay, or you can consider k is a constant, some constant. Okay, so as for example, yk is given here. So suppose 2x squared minus 2, this is a polynomial. Yeah, so if take common 2x squared minus 1, then 2x plus 1, x minus 1. So understand? So sometime there is a constant. So this constant we consider as k. K is a constant. So if you multiply these two, then you get x squared minus alpha x minus beta x plus alpha beta. Yes. So k common, x square minus alpha plus beta x plus alpha beta. Okay. Then you compare these two, this and this one. If you compare these two, then what you will get? Minus alpha plus beta is equal to b by a, and alpha beta equal to c by a. So therefore, if you comparing these two, then you get minus alpha plus beta is equal to b by a. So this implies alpha plus beta is equal to minus b by a. This is the one relation. And another relation is alpha beta equal to c by a, and you get alpha beta equal to c by a. Okay, this is another relation. So these two relation is called the relation between zeros and coefficient. So alpha plus beta means the sum of the zeros equal to minus b by a. What is minus b? What is the b? B is the coefficient of x. Divided by a means coefficient of x squared. And this is the product of the zeros. Product of the zeros is constant. Constant by a. Constant is c, and a means coefficient of x squared. So now we write a very important note. Important note. For any polynomial, for any quadratic polynomial whose zeros alpha and beta can be written is of the form x squared minus alpha plus beta x plus alpha beta. This is the polynomial whose zeros is alpha and beta. Or this one you can write in some book, it is written this way: x square minus alpha plus beta x plus alpha. But both are correct. Okay. Now division algorithm of polynomials. Actually this already discussed in Euclid division lemma. What is Euclid division lemma? A is equal to b cube plus r. What is r? R is the remainder. It greater than 0 or equal to 0 and less than 0. Okay. Okay. So in this case, just you put the polynomial here. So a, in place of a, suppose you put px. In place of b, you put suppose gx. In place of q, you put suppose qx. And in place of r, you put suppose rx. So this is the polynomial. So therefore, it is called division algorithm of polynomials. And this one is the division algorithm of the integer, positive integer. And this is the division algorithm of polynomials, where degree of rx, yes, because this is not an integer, positive integer, this is a polynomial. So degree of rx is greater than or equal to 0 or less than degree of gx. So understand?
Students, today we learned some very basic points about polynomials, like types of polynomials, zeros of the polynomials, degree of the polynomials, relation between zeros and coefficients, division algorithm for polynomial, and we also discussed some very related problem about polynomials. Okay, so I think your concept is clear about the polynomial.
Thank you.